Something strange just entered our solar system. Again. But this time, it's not an asteroid, not a typical comet, and definitely not something we've seen before. Meet Comet 3I Atlas, a mysterious visitor from another star system now racing through our cosmic neighborhood at breathtaking speed. Scientists are scrambling, telescopes are turning, and theories, some wild, some grounded, are flying everywhere. What exactly is this thing? Why does it behave so differently from every comet we've ever known? And could it really, possibly, be something artificial? Get ready, because what astronomers just discovered about 3I Atlas might completely change the way we understand interstellar objects, and maybe even life beyond Earth. Back in July 2025, NASA's Atlas Survey Telescope in Chile picked up something unusual. A faint, fast-moving point of light cutting through the stars. At first glance, it looked like another comet, but when researchers traced its orbit backward, their jaws dropped. This object wasn't from our solar system at all. It came from somewhere else. Designated 3I Atlas, it became the third known interstellar object to ever enter our system, following in the footsteps of Oumuamua in 2017 and Comet Borisov in 2019. But here's the twist. 3I Atlas is nothing like them. Let's rewind for a second. When it was first spotted, 3I Atlas was still faint, a dim traveler hurtling through the darkness. But calculations quickly revealed its incredible speed, nearly 58 kilometers per second, or about 130,000 miles per hour. That's fast enough to circle Earth in under 7 minutes. And this isn't a young object. Early estimates suggest it could be as old as 11 billion years, older than our solar system itself. For months, astronomers gathered every shred of data possible. And since that first discovery, research papers have exploded, from just 4 in July to nearly 70 by September. The race to decode this alien visitor had officially begun. But before we get into the new revelations, let's quickly recap how we got here. Like Borisov and Oumuamua, 3I Atlas came from interstellar space, meaning it was formed around another star, possibly ejected billions of years ago when its home system was young and chaotic. It's been wandering ever since, until it finally stumbled into our solar system in 2025. When word spread, Earth's most powerful telescopes turned their gaze toward this strange visitor. First up, the Hubble Space Telescope. It's notoriously hard to get observation time with Hubble. Scientists have to submit proposals months in advance and fight for every second. But 3I Atlas was special, a target of opportunity. Meaning, if we don't look now, we'll never see it again. Hubble captured a stunning image of 3I Atlas on July 21st, when it was 446 million kilometers away. The photo showed streaky background stars, a telltale sign of the comet's blistering speed, and a distinct teardrop-shaped coma trailing behind its icy core. From that image, astronomers estimated the nucleus to be somewhere between 440 meters and 5.6 kilometers wide. Much smaller than they first thought. Why? Because earlier, scientists assumed the brightness came entirely from the core. But now we know much of that light comes from the dusty coma, the cloud of gas and ice surrounding it. And Hubble wasn't the only telescope watching. The mighty James Webb Space Telescope, JWST, joined in, using its near-infrared spectrograph to peer into the comet's chemical makeup. That's when things got weird. JWST detected a complex mixture of gases, primarily carbon monoxide and carbon dioxide, with surprisingly little water vapor. That's the opposite of most comets, which are dominated by frozen water. Even stranger, 3I Atlas was releasing dust toward the sun, not away from it. That shouldn't happen. Normally, solar radiation blows a comet's tail in the opposite direction. But in this case, something about the gas dynamics, possibly violent bursts of CO2, was pushing material in the wrong direction. Whatever 3I Atlas is made of, it's not ordinary. Then came another surprise. NASA's TESS satellite, built to find exoplanets, wasn't even supposed to study comets. But when scientists dug through old TESS data, they found something incredible. 3I Atlas had actually been recorded by TESS months earlier, all the way back in May 2025. This gave astronomers a longer timeline to track its brightness, and what they discovered left them stunned. Between May 7th and June 2nd, as the comet moved closer to the Sun, its brightness didn't just increase a little, it exploded. Instead of brightening by a factor of 1.5, as predicted, it brightened by 5 times that amount. That means it became several times more active than scientists thought possible. This incredible outburst suggests that 3I Atlas isn't just a dead rock coated in ice. It's a dynamic, volatile body, spewing material even at great distances. In fact, calculations suggest it began outgassing when it was still 6 astronomical units from the Sun, far beyond Jupiter's orbit. For most comets, that's way too cold for activity. So, what's fueling it? Possibly exotic elements like nitrogen or hydrogen, materials that vaporize even in the distant cold. The more we learned about this object, the stranger it became. By late August, Earth-based telescopes joined the chase. Using the Gemini South Telescope in Chile, astronomers captured detailed multicolor images showing not just the coma, but a long, faint tail. Its length, roughly 1/120,000th of a degree across the sky, much larger than previous observations. And this tail keeps growing as the comet approaches its closest point to the Sun, or perihelion, expected on October 30th. But then came a chemical bombshell. Spectral data from Gemini detected something unmistakable: cyanide gas, hydrogen cyanide molecules being released from the comet's surface. This is typical for many comets as they heat up, but it told scientists exactly how active 3I Atlas had become. Researchers calculated that it was ejecting nearly 800 sextillion cyanide molecules per second. That's 8 times 10 to the 23rd power. A staggering number, even by cosmic standards. However, the comet's overall chemical signature revealed something even stranger. Its carbon chain depleted. That means it lacks longer carbon molecules like C2 and C3, which are common in normal comets. Borisov, another interstellar comet, showed this same signature. So maybe, just maybe, there's a hidden pattern here. A clue to how comets form around other stars. Are interstellar comets born in environments poor in carbon chains? Or do they lose those molecules during their long, lonely journeys through space? No one knows yet, but 3I Atlas might hold the answer. While most studies focused on brightness and composition, one research group decided to look at something deeper: polarization. In early September, astronomer Zuri Gray and her team performed the first ever polarimetric analysis of 3I Atlas. This measures how light scatters off an object, revealing details about surface texture and dust structure that normal imaging can't see. Their results? Completely unprecedented. 3I/ATLAS showed an extremely deep and narrow negative polarization pattern, something no other comet or asteroid has ever displayed. For comparison, Borisov had positive polarization, meaning light scattered perpendicular to the Sun-comet line. But 3I Atlas, it's the opposite. The light is scattering parallel. This suggests its dust grains or surface properties are fundamentally different. Maybe more compact, more reflective, or shaped in a way we've never observed before. In short, this thing's physics break the rules. And it's not just scientists seeing something strange. On September 7th, during a lunar eclipse, 2 amateur astronomers in Namibia, Michael Yeager and Gerald Raymond, captured a breathtaking photo of 3I Atlas glowing bright green. That glow usually comes from diatomic carbon, C2, which fluoresces when energized by sunlight. But remember, 3I Atlas is carbon depleted. It shouldn't even have that molecule in large amounts. So, how was it glowing green? One theory is that as the comet gets closer to the Sun, it begins releasing deeper layers of material, rich in compounds we couldn't detect before. If true, That means the comet's chemistry is changing in real time, evolving right before our eyes. That's the beauty and the mystery of a living, active interstellar visitor. Now let's talk about the elephant in the room. Whenever something strange appears in our skies, one name almost always pops up: Avi Loeb. He's a Harvard astrophysicist known for his bold and sometimes controversial ideas about alien technology. You might remember his claims that Oumuamua could have been an alien probe. Well, he's back. In July, right after 3 I-Atlas's discovery, Loeb published papers suggesting it was too large to be a natural comet. He argued that given how rare interstellar visitors are, a 10-kilometer wide object entering our solar system is statistically improbable. Then, in a follow-up paper, he and his collaborators asked the question directly: is the interstellar object 3 I-Atlas alien technology? Their reasoning? The object's unusual brightness, unpredictable trajectory, and energy emissions might, hypothetically, be consistent with artificial propulsion or engineered material. They even referenced the dark forest theory, the idea that intelligent civilizations might hide or camouflage their technology to avoid detection. But most scientists weren't convinced. As more data came in, new Hubble measurements showed that 3 I-Atlas is much smaller than Loeb's estimates, only about 5.6 kilometers wide at most, not 10. And updated trajectory data explained its path naturally, without requiring alien engineering. Researchers like AKM Easanulhake published rebuttals, demonstrating that the comet's motion could easily be explained by standard gravitational dynamics and gas outgassing. In other words, no aliens needed. Still, Loeb's ideas, while controversial, remind us that sometimes science advances by challenging the norm, even if it turns out to be wrong. So, where does that leave us? Right now, Comet 3 I-Atlas is speeding toward its perihelion, its closest point to the Sun, on October 30th. Unfortunately, it'll be too close to the Sun to observe directly. But once it re-emerges in December, telescopes across the world will lock on again. NASA's SOHO, SPHEREX, and MAVEN missions are all lined up to study it, alongside Hubble, James Webb, and Gemini. Every new observation will peel back another layer of mystery, revealing more about its structure, chemistry, and origin. Will it survive its brush with the Sun? Will it fragment like many comets do? Or will it surprise us yet again with something completely unexpected? Whatever happens, one thing's certain: this story is far from over. 3 I-Atlas is more than just a comet. It's a messenger from another world, a frozen time capsule carrying secrets from a star system we may never visit. And as it passes briefly through our corner of the cosmos, humanity gets one rare chance to look, to study, and to wonder. Because the next time an interstellar visitor appears, it might not look anything like this one. From its ancient origins to its strange chemistry, from glowing green mysteries to alien speculation, 3 I-Atlas has already changed how we see our place in the universe. It's a reminder that the cosmos is alive, full of travelers, stories, and surprises waiting to be uncovered. And maybe, just maybe, the next visitor won't just pass through, but will finally bring us the answers we've been searching for.